Alright, let's look at the practice exam 3, problem number 9. Alright, so we have a partial sum given, Sn equals n minus 1 over n plus 1. Then we want to find an and also the sum. Alright, so let's find an. Alright, so remember that the partial sum, alright, partial sum Sn is just going to be a1 plus a2 plus and so on, and the last one is let's say n minus 1 and an. Right, and we are interested in getting just an, so this is the guy we're interested in. So we need to get rid of an through an minus 1. Right, but we can get that by just looking at this partial sum Sn minus 1, because this will give you exactly what we want, a1, a2, and this only goes up to an minus 1. Right, so what we can do is go through this subtraction. Then you will get Sn minus Sn minus 1 is equal to, alright, so you see that the a1 minus a1 cancel out, a2 cancel out, all these guys in between cancel out, an minus 1 cancel with that, so what's left is just going to be an. Right, so we can find an by Sn minus 1. Right, so here. Right, so Sn is n minus 1 over n plus 1, because that's just given. Right, then we have to subtract Sn minus 1. Right, so which means that we can just replace n by n minus 1. So you have n minus 1, then you have extra minus 1, so it's n minus 2. Right, on the denominator, you have n minus 1 plus 1, so that will be just n. Alright, after that, we can just take the common denominator. So you multiply n plus 1 and n together. Alright, so we have to multiply the numerator by n, so you get n squared minus n. So there's a negative sign, so minus. And we multiply n minus 2 and n plus 1. So it's going to be n squared, right? Then you have, maybe I'll distribute n times negative 2 would be negative 2n. And 1 times n is going to be plus n. And 1 times negative 2 would be negative 2, right? So we just need to simplify this here. We have n squared minus n squared. Cancel out, and then what else do we have? So you have here negative 2, maybe I should do this, if you combine this, right, so you get the negative 2n minus n is negative n, right? Then you can cancel here, so negative n minus negative n, that means that you're canceling those. Alright, then what's left is simply, right, negative 2, so that's positive 2. Right, and then I like to put the n in front, then you have n plus 1. Alright, so this is going to be the expression for an. Alright, and once you found that, and finding the sum is very, very easy, because since we already have the partial sum, so by definition, sum is going to be the limit of the partial sum. So you take the limit as n approaches infinity. Right, so partial sum is n minus 1 over n plus 1. Right, so we can multiply top and bottom by 1 over n, 1 over n. Then this is going to be, oops, I didn't write the n there completely. Right, so this is going to be a limit as n approaches infinity. Right, So n divided by n is 1. Negative 1 divided by n is negative 1 over n. N divided by n is 1. 1 over n is 1 over n. All right? So we know that as n approaches infinity, 1 over n approaches 0. And the same thing down here. All right, so what's left is 1 over 1, which is 1. All right, so that is the sum of the infinite series. All right, that's it. I hope that this was clear.